One question, one answer, designing seamless AI agents with C#. I'm Mark Miller. This is me essentially right here, at least in bullet form. I do this right here, work for that company right there. We're going to talk about this one query, one answer strategy combined with deltas there and how it can outperform linear chat-based experiences. We're going to talk about getting the right context, and we're going to talk about UX and design principles briefly, and we'll wrap up with patterns for great AI experiences. That's where we're headed. So 1Q1A plus deltas, we're going to introduce and compare the model, and we'll compare it against a typical linear AI chat with agents. And we'll take a look at what the differences are from three perspectives: the user's perspective, architecture, and the data. So let's get right into the essence. Well, it's a single user question or command. Rich context is going to be quickly determined, collected, and sent to a strong reasoning AI. Short delta AI response is going to be coming back, and we're going to have that handled by our agents. And the agents can integrate the changes and execute commands. All right, from the user perspective, what does it look like? I'm going to switch over to Visual Studio, and I've got an application that I'm running called My Extensible Calculator. I'm going to just hit a couple buttons on that. 88, say times 3 should be about 264. There it is right there. Great. Now let's go into this interface called I Can Calculate. I'm not using it yet. I've just built part of it right here. Let's extend it. Oh, before I do that, let me show you my control key. I've got a live camera on it. Hey, I would like to add two properties to this. One called button text. That's for some short text that's going to show up in the button. And another one called hint.
Adding the button text and hint properties to the main window class now.
All right, great. Now I want you to create 8 implementers of this interface. And I want you to focus on advanced calculations. You can ignore the simple ones like plus, minus, divide and multiply, or negate.
Creating 8 advanced implementers of the I Can Calculate interface now.
All right, here they are. We can use shortcut keys to look through them. We start with the ABS calculator, absolute value, factorial. Take a look at what's showing up in that button text right up there. That's exactly what I want. Nice and short information there. There's the power, log, square root. Looks good. That's exactly what I want. By the way, this interface in the back, hidden behind me, this shows me what changes are here. I can navigate to those. I can bring up a difference view to see what's going on. That allows me to approve afterwards. Well, it's one way to take a look at the code after we're done making changes. Over on the main window, I'm going to do this. Hey, when we start up, I want you to go through all the types in the solution. I want you to find any implementers of I Can Calculate. I want you to instantiate that type, and I want you to add that instantiation into a list of I Can Calculates. And I want that list to be a public property on this form called calculators.
I will gather all implementers of I Can Calculate, instantiate each, and add them to a public property called calculators on this form.
So take a look at the speed, right? The speed at which we're making these changes, right, as we're going through. Get a sense of what that is, right, up to this point. Let's see what we have here. We're clearing all the calculators. I like that. Good defensive code right there. We're getting the types out of the current assembly. And what are we doing? We're checking to see if it's not a class. Well, if it's not a class, that means like an interface. We're going to continue. Or if it's abstract, we're going to continue. If it's assignable from, that's key and very important. And then we are going to create an instance of it right there and add it to calculators. Okay, great. Hey, on the form, I've got an extensible area. I want to populate that with a rectangular array of these calculators, this calculators property that we have of I Can Calculate instances. I want you to populate that with buttons. Also, the I Can Calculate interface has a property called hint. That should be in the tooltip.
I'll prepare the context to help you populate the extensible area with buttons for each calculator, including tooltips for hints.
Right. And when this is done, I'm just going to hit run and we'll take a look at that and see how that works. Okay, I'm hitting run. Nice. Okay, take a look. There's the 8 buttons that we have right in there. Let's hit 8 and squared, and we get 64. Pretty cool. So AI plus agent change UI. With a typical AI chat user experience, we start with the user prompt or the query, whatever that is. Now, to get there, we often need to leave the code, the data, the part of the app that we're in, that we're working in. And we have to find and activate the chat tool window. And then we type in our prompt. We wait for the response. We visually scan the response. We are looking sometimes for signal through a lot of noise because AI often likes to be very helpful and give me some contextual information before and after the essence of what I need. If there's integrations, we will pre-approve those integrations, usually with some sort of preview window. And then we'll wait for the integration to complete and we'll repeat for each distinct segment that needs integration. We might also simply review manually, select the code we need or select the data we need, copy that to the clipboard, move back over into our application where the data is, and we'll select or position the cursor there and we'll paste that in. And again, if there are multiple of these segments that need integration, we're going to repeat that for each distinct segment needing integration. So where's the pain? So using an arguably biased and arbitrary scale, the pain scale, my pain scale, I'm going to rate these different areas in terms of what their overall influence is on my personal pain. So up here, I give it a +3 on my scale. And my scale is basically going from 1 to 5, where 5 is kind of a really big deal. So here I've got a +3 right here because I have to leave the code, leave the data, find and activate the chat tool window, and then start typing. Right over here, waiting for the response. I don't like to wait, so that's always a pain for me. Over here, finding signal through the noise. Sometimes this is really, really painful because I'm sometimes having to compare the code that's presented back against code I already have to visually find in 2 different windows where the differences start. And then I can realize, okay, here's the new stuff I need, followed by the end, finding the end. Where do the differences end? So for me, that can be sometimes quite painful. Waiting for integration. If integration is slow, that can be very frustrating, especially if you have multiple integrations that need to take place. Switching between tool windows, that's not too hard. That's just a simple, going to find it. Reviewing, well, that's another +1. Selecting, sometimes, in fact, often, like for example, I've been working with ChatGPT in a web browser. ChatGPT will have using statements up at the top and maybe a namespace, things I don't need at all. So instead of just hitting the copy button, that makes it easy because now that's going to make my paste harder on the other side. I'll select inside of that. And so there's a +1 for me for that, for selecting just the class, because sometimes the class is big. And so I have to go at the start, select all the way down to the bottom. There's scrolling involved. It can be some pain in it. There can be some pain there. Selecting back on the other side. So I switch the tool window back to the other side. Maybe that's another +1. And I have to now go find the right code to remove or the position to insert the data, whatever I'm doing. I need to find it, select it, move the insertion point to the right spot. That's painful. Now, if we compare the models, that's the typical AI chat user interface. The 1Q1A looks more like this. The user prompt query. Notice, by the way, how thin that is right there, how narrow that is, how short it is. This is time flowing down. The reason that's so narrow is because of 2 things. One is we don't have to go find a window to go work in. We don't have to click the mouse to activate it. We don't have to find it in a menu to bring it up. We don't have to go find it, number 1. And number 2 is we're using voice for this. You could use text as well, but when you use voice, which I recommend, you can get out about 3 times as many words in the same time as you can with text. Voice is 2 to 4 times faster than text. That's why that's so short right there. Then we are going to wait for that response. Now, that wait time is shorter here as well, because one of the things that we're doing is we've got that plus deltas on the model, which means we're asking for deltas only from AI. We are not asking for AI to give us any contextual code at the beginning or at the end. We're simply asking for the changes. And then later we're going to go implement those changes. Those changes instantly are integrated. They happen immediately. There's no preview in this model. right? The approval comes after the changes. I'll explain why a little later. You can review those changes, as I think you saw in that demo. I was going through and looking at those changes very quickly. You can also simply compile, run, and test. Right? You can do all of those things, or you can just visually scan. Sometimes the changes are so simple, you just look at them and say, yep, that's what I needed. And it makes sense in those cases to not have that separate UI where I have to go click on something to approve it. By the way, for this reviewing, we can make that faster using familiar navigation shortcuts. I've listed F8 and F7, which are inside Visual Studio for navigating between errors. We can use those same shortcuts when we're in this mode of reviewing those changes. So where's the pain over on this side? Well, I'm still going to give this about a 0.5. Voice works well up to about a paragraph or so. And the reason why is because it takes a lot of cognitive load to be speaking for a full paragraph in terms of a spec. So I like to go about a paragraph and a half, and then I stop. In the demo, I was actually going pretty shorter than that because I wanted to show this a piece at a time, but there's nothing that would stop me from doing everything in the demo in a single paragraph. What else? I have waiting for the response. I got about a 1.5 there. The review process, it still takes some work. You've got to go look through it. The pieces at the end of there, that's kind of where the pain is. The difference in these two is looking like that, again, on my totally biased arbitrary scale. Now, from an architectural perspective, what does it look like? Well, the user says, hey, let's fix this, or let's do something, or I need this code, or I want this document, whatever that is. The user asks a question. In the 1Q1A architecture, we send that question to a tiny, fast AI. And that fast AI is responsible for determining what context is going to be delivered into a much larger advanced reasoning AI. And that advanced reasoning AI comes back with an answer, ideally in the form of deltas, and the deltas are integrated back into the data. That's essentially what it looks like in cartoon form. So our approach, well, we take the speech and we send it to Azure and we get text back. That comes back in about 400 milliseconds. We send that to the tiny AI context query. That is an expert at determining essentially what information do we need to answer this question. And we recommend a cheap, fast model for this, like we're using GPT-4.1 Nano for this. Then we go on to context collection. We might go into one or more context providers, like we can look back into chat history, look at source code for types. Again, this is in the context of a Visual Studio agent. So for source code, so we might look at debug values if we're debugging, the error list. We might go out to MS Docs, MCP server out there to get some official Microsoft documentation to answer a question. All of this, where we go is all determined by this AI context query up here. By the way, the MCP results can be slow, like a second and a half waiting for some results, and they can return big results. So if you're focused and hyper-focused on time, there are some things you're probably going to want to do here to optimize for MCP integration. I've just got an example over here of an interface, an AI context provider that essentially represents the interface that these guys implement. And it basically returns, it's got a method called getContext that returns a list of context slots. A context slot has a priority and it's got a bunch of fills. Those fills are different size versions of the text needed to send to the big AI reasoning model. So looking visually something like this, all the same document, but different sizes. Why? I'll explain why right now, because it's something called optimal context window packing. What we want to do is we want to take potentially a lot of information and get it to fit into a small space, the context window that AI supports. Typically, especially with source code, it is easy to blast past that window. For example, on huge solutions, simply a list of all the type names in that solution can blast through context, the biggest context windows that we have available. So you can't even say, here's all the list of all my types, for example, right? So we have to be very clever about how we're going to pack that context window. Once we get it packed, we send it to our main reasoning, advanced reasoning model, our main AI query. We're going to add some UI here to speed up the wait time. So we'll do some animation. We'll have maybe some audible feedback during this time so that the perceived wait time seems less. When that comes back, we've got Delta integration. Ideally, again, if you choose that Delta option of the model, which I highly recommend, it's got benefits all over the place. Those changes go in fast with a one-step undo. Right? There's no preview. There's no prior approval. The changes are made. And if you want to undo, you can just undo all of them at once. And finally, we go from there to the navigation and review stage of this. What we want there is we want to have some navigation shortcuts, some change diffs, things that make it easy and fast to review and approve the changes. And that's our approach. So I mentioned before that we have these context slots, which consist of essentially the same data in different sized representations. The context packer selects the best optimal fill, places those inside the context window. So that's one of the ways that we're looking at data a little bit differently. And the other piece of the data that's kind of interesting is what's coming back from AI. We're asking for very, very small delta changes. That cuts down on token count, and we're talking about the output token count, which is generally about 4 times more expensive than the cost of handling the input tokens. So it's a lower cost, a lower energy consumption, and a lower CO2 burn as well. So asking for the deltas makes sense, and having the ability to integrate them immediately makes sense as well from a performance standpoint. So chat history or none at all. Well, what are the implications of a chat history user interface? I like to think of a chat history interface as a little bit like an asteroid with a long tail stretching out behind it. And it brings some problems. It's linear by nature, so branching is costly. One of the things that often happens to me when I'm using like ChatGPT is ChatGPT will say 5 things and point 2, I want to go discuss. But then when I'm done, how do I get back to point 3 fast and easy? That takes time, that takes energy. This linear UI does not accommodate branching well. MCP integration can be slow and noisy, and manual changes are difficult. In this UI, it involves scrolling, selecting text, copying to the clipboard, switching windows, moving the caret or selecting the text that you're going to replace, pasting, switching windows back, and repeating. And token counts can go much higher than needed. The right context. So the proposition here is that maybe the chat history UI that you're seeing everywhere is not always 100% the right context. At the start, you've got nothing. It's stateless at the start. And at the end, you're carrying old baggage along with you. There's something that doesn't quite feel right about that. And maybe your application's environment and data are enough. Maybe they're sufficient. The data is super fresh, right? What's alive right now inside my solution or inside my application, that's the state that I'm at. That's the most important state right there. That's the fresh data. And forward intentions can always easily be expressed. And LLMs rarely need knowledge of past actions to make good decisions moving forward. They just need the right context. And if you really thought that that was important, you could implement an AI-guided selection of recent history or memory. That could be useful. It can help you maintain the original spec, and it could be useful for correcting course, where you say, no, not like that. Do it this way instead. However, undo and retrying can often be faster and use fewer tokens than trying to correct the course. Let's do a demo compressing context. This is the context packing demo. It allows me to select a variety of context slots. So I can say how many slots I want. I can click the regenerate button up here, get different variations. And then down here, I can specify the size of my context window. If I make it big enough, everything fits in the largest size available in all of these context slots right here. But notice as I start to compress it, it's taking from the lowest priority ones first, and it's dropping the sizes of those, getting this thing to fit. So we can still get all of the pieces of information there into even a very tiny context window. All right, UX and design principles. So the number one rule is efficiency is everything. You want to minimize movement, you want to minimize thought, and you want to minimize wait times. So minimizing movement, that means we're reducing mouse moves, mouse clicks, key presses, eye gaze shifts, voice, number of words spoken or written, right? If I can get you to do what I want you to do by just saying fix it, that significantly reduces the user burden. How can I get there? By having a rich context that I'm supplying to AI. That's why it's so important to be able to know where you are in the application and not have a dedicated window. User steps, we want to reduce the number of steps that it takes to get something done. Device transitions, going from the keyboard to the mouse or the mouse to the keyboard, we want to reduce those transitions as well. Minimizing thought, right? We want to reduce the cognitive load. Your emphasis must match the importance of the data that you're putting out there. The slide bullet point demonstrates itself. Down here, bullet point number 2, proximity matches relatedness. This is the second mistake that people make very frequently. Things that are closely related are often put farther apart than they should be. They need to be close together if they're closely related. Similarly, things that are vastly different, like a save versus a reformat my hard disk, should be far apart, not close together. Notice the important information is higher contrast. The less important information, this line, for example, right here, is lower contrast. So emphasis matches importance. We've got some proximity here, that this is close to that, so we kind of can see it. I would actually bring this in even closer. I think the distance here is arguably too far. I'd bring that a little bit closer in over here. Notice here, this is related to that, but it's over here aligned up here. We've got alignment also that we're using because these are all related. I'm okay with this because we've got these lines here that are guiding us, that are telling us, look, this space is kind of all together. But then again, this line should go even further to include this, shouldn't it? So there's both good and bad in here. One of the good piece right here, take a look at this. This is information showing how to do this. It's in a smaller font, and it is in a lower contrast. It is not as important as the other data up here. You want to minimize wait times. We're talking about everything, and you want to do it as fast as possible. What are the implications of this? Well, you want to prefetch your MCP calls early. You've got an MCP server that gives you a list of potential documents that could match a query. You want to run that as soon as you have the text back from Azure. Context collection, you want to run this in parallel. So all those context providers, they are doing all of their work in parallel. Delta change integration, it's really the only way to go if you need speed. It both reduces the output token count, so you get your responses from AI faster, and it's very, very quick to integrate into the solution. Considerations, well, something you can think about. This is future, not something we're doing yet, but something on my mind, which is to be able to spawn multiple simultaneous agent instances to all work together on the same data set. It is possible to do. I know it's problematic. I know there's problems. There's all kinds of what-if gotchas that you're thinking about probably, but I think it's a solvable problem. And if you can solve this problem, then this idea of wait time completely goes away. I can say, hey, do this, and oh, hey, while you're doing that, do this now. And so we've got now 2 agents that are spawning up that are working together on the same data set. Patterns for great AI experiences. So the 1Q1A model, I'm essentially proposing it as a good design pattern for AI. That includes dynamic context collection, and within that you've got priorities, you've got optimal context window packing, and you definitely want to include rich context from your environment. It also gives you an opportunity to control the prompt context and key properties of the reasoning AI query. So our tiny AI model can come back and tell us how to change the prompt, how to change the context, and maybe even set key properties on the reasoning AI query. Key properties like reasoning effort and verbosity, for example. Voice input. It's up to 4 times faster than typing. If you're concerned about productivity for your users, consider that. And I strongly recommend a push-to-talk mechanism. This is how we did ours. We use the control key, or we tap it once, and then we hold it down and we say whatever we want to say. And while we're talking, we continue to hold it down. And when we're done, we lift it up, and then we send the text that comes back from Azure Speech Recognition off to AI. It also gives you easy support for 100+ languages. And voice allows access from anywhere inside the application. And if you're using voice input, make sure your contextual references are rich based on the app focus and state. That allows the spoken words or the typed words to feel more intuitive and to be shorter. So I can say shortcuts like fix this everywhere it's happening, and hey, when did this get reversed? That's all I have to say, and AI can come back with the right answer. Optional voice feedback. This is what the user can hear. This gives you a free win in terms of compressing perceived wait times. I actually love this inside of our implementation. It works really well. And also, the user gets confirmation that the reasoning model is on the right track. The tiny AI, the context model, basically says, here's the right track, and we get that confirmation. We give that to the user in terms of that voice feedback, or it could be also on screen as well. And this fits really well in the 1Q1A model. And just like input, with output, you get easy support for 100+ feedback languages and voices. Okay, Delta change integrations. I think that's a big deal. That gives you those faster response times, reduced AI costs. Command invocation is a possibility where we can invoke commands and really control the application based on me telling it what I want it to do, rather than finding a menu item, for example, or hitting a shortcut. Quality control checks on the AI response. That's important. You want to be able to validate the correctness of the response, and you want to be able to redirect hallucinations. For optimal user efficiency, you want to make all changes immediately. Don't preview them first. Now, ignore this bullet point here if you've got mission-critical applications where any mistake can be very costly or deadly without undo. Feedback while waiting. We use color-coded, motion-coded status. Looks a little bit like this. So when we're listening, we have a minimal animation, just enough to show you that, hey, something is happening, but not too much to be distracting. We don't want to distract you while you're talking. When we're collecting context, we have tiny dots moving faster to represent that tiny AI that's collecting context. And when we go to reasoning, we have a larger, slower motion here. And all of these are here to subtly reinforce what part of the architecture is active in the moment. You want your visual feedback in close spatial proximity to customer focus, so we're minimizing our eye gaze shifts. Audible feedback needs to be in close temporal proximity, the end of the user prompt, especially when using the 1Q1A model. Tiny AI context query can return the voice feedback message to say or to put on screen. You want to keep the UI close to the data. Avoid separate modes or windows that have to be activated or found to invoke the AI. And this provides more context than a separate chat window, right? We get to know exactly where you are. Are you in the watch window? Are you in the error list? We know where you are and we can act on that. Agency over the process. So this is important. And of course, we need a cancel button there so we can stop a process going in the wrong direction or taking too long. We need to be able to undo all our changes with a single press of Control-Z. We need fast navigation through all the changes for our review with a difference view. That's important. And I think it's useful to be able to tweak prompt and functionality settings after the context query, but before we get to the main reasoning model, such as suppress data formatting after integration. I really want you to think this through. Logging is important because AI service providers offer indemnification clauses. Those clauses are there to protect users against claims of copyright infringement. In order to be protected, the users must provide proof that the code or data in question came from the AI. Other advantages to logging: it documents the spec and the user intention in the prompts. It helps tech support investigate customer issues in greater detail. And you can even do test case generation. We're actually doing this where if anything goes wrong or if the customer has a support issue, they can send us that .test extension file, and that has all the code we need. It's C# code to recreate what happened in that instance for the customer. It also makes it easy to track AI usage and cost as the user works. And that's it. You can find me here 3 days a week, and I hope you enjoy the rest of the conference.